Okay, so I want to take a look at a different method in order to factor quadratic trinomials where the leading coefficient is something other than 1. It's called Lizzies method, and it'll take a while to get used to. There's quite a few steps, but a lot of times people find this a lot easier than just trying to plug numbers in and test them. So what I want to try to do is use first the diamond method that we took a look at in 7.5. Here's what you have to recognize, though, that in this trinomial, A is 3, B is -7, and then C is 2, because this quadratic trinomial or polynomial is in the form of ax² plus bx plus c. So the first thing that I want to do is create my diamond. It's a little bit different now. On the top of the diamond, what you'll always put is whatever A times C is. So in this case, 3 times 2, that's 6. And then on the bottom of the diamond, I'm going to put what B is. So in this case, that's -7. And then I want to find two numbers here on the left and right sides that multiply to this top number and then add to the bottom number. So these two numbers here again should multiply to the top number. They'll always multiply to the top and at the same time add to the bottom. So I want to try to find two numbers that multiply to +6 here and add to -7. And the two numbers that multiply to +6 and add to -7 are -6 and -1. Order here doesn't matter. I could have put -1 and -6. Order definitely matters in my diamond, though, on the top and bottom. Okay, now what I want to start doing is building my binomials with these two numbers. So I'm still trying to factor this polynomial into the product of two binomials. And I'm going to take these two numbers. My variable here is x. It's x -6. So I'm just going to put them in as the last terms of each of the binomials and x -1. I'm not done yet. Okay. Now what we want to do is divide each of these two numbers, the last terms of each binomial, by a. In this case, that's 3. So it's -6 divided by 3 and then -1 divided by 3. Anytime we have fractions, I always want to try to simplify it. You can simplify this. So anytime you have fractions, definitely simplify. -6/3 is -2. So that would become x -2. This is already simplified, or in other words, it doesn't simplify. So if you can't divide a evenly into 1 or both of the numbers, like 3 doesn't go evenly into -1, then you bring it in front of x, or whatever your variable is. The variable doesn't always have to be x. So then that becomes 3x, and then we have the -1 since I brought the 3 in the denominator in front of the x. If you remember, when we factor this using like the plug and test method or just kind of messing around with the numbers, we came up with the exact same thing when I wrote it out. If you go back to the first video, it's actually 3x -1 times x -2, but it's actually the exact same thing. We'll take a look at other examples because the more you do Lizzie's method, then maybe the easier you'll find it and possibly prefer it as a method to use. So the second example, we already factored using just the regular old-fashioned method. I'm going to factor this using Lizzie's method. If you notice on the right side, I actually wrote down all the things that you would need to do using Lizzie's method. So the first thing that I want to do is list what A, B, and C are. I can just label them right by the numbers. A is 5, B is 17 or +17, and then C is a -12. Then I could start building by diamond. What should go on top here is A times C. So 5 times -12 is -60. And then what should go on the bottom is B, or in this case, 17. So now I want to try to find two numbers that multiply to -60, and then those same two numbers add to 17. So if they multiply to a negative, before we figure out the numbers, we should know that one is positive and one is negative. That's how you have to multiply two numbers to get a negative. And you should be able to figure out that the larger of the two numbers has to be positive. If they add to 17, then 17 is positive. The larger number has to be the positive number. See if you can figure out what works. And then if you figured out what works, I called those numbers in my Lizzie's method notes just P and Q. So what should work is +20 and -3. 20 times -3 is -60. 20 plus -3 is 17. So these two numbers, P and Q, P is 20, q is -3, have to multiply to a times c, that top number. They have to add to the bottom number, and then they do. So now I'm on step 4. I can start building my binomials. X plus 20, and then x plus -3, or just x minus 3. That's this part right here. Now I divide each of those numbers, p and q right here, by a. In this case, 5. That's what I did here. I want to simplify the fractions if possible. 20 over 5 definitely simplifies. 20 over 5 is 4. -3/5 doesn't simplify, so you want to bring a, in this case 5, if you can't simplify it, in front of x. This comes in front of x, so it's 5x minus 3. Again, if you go back to video number 1, we came up with the exact same two binomials, but this is just using what's called Lizzie's method.